So first we need to talk about is the greatest common factor. Since again, I'm assuming that you've done some sort of factor, I'm just going to start you off with an example, and then we're going to, discuss how that works. So, for example, if I give you this expression, 5x minus 15x squared. Okay, so it's just a simple binomial, and I'm asking you to find the greatest common factor, meaning an expression that is a multiple of both of these terms. What do you think that is? 5x, right? The greatest common factor is 5x, right? Because both 5 and 15 are multiples of 5, and x squared are multiples of x. So if I were to factor 5x out, what is left in the parentheses? Who's good at this? No. So if I take 5x out, how do you know what's left in the parentheses? What? Just the 3? Yeah, got to be 1 minus 3x. That's right. So the way you do that, when in doubt, just divide. Somebody said divide. Divide each term by the greatest common factor. 5x divided by 5x is 1. 5x squared divided by 5x is 3x. Is that okay? You can always, the nice thing about factoring, you can always run a quick check to see whether you got the right answer. If you distribute 5x through the parenthesis, you should be getting your original problem back, and you do in this case. Now, don't forget about that 1. It's important to have 1 in there. It's kind of a placeholder if you take an entire thing out. But if you just stick to the idea that you have to divide each term by the greatest common factor, then you'll get the right answer every time. Okay? So the steps in finding GCF, first, find numerical, find the largest numerical factor. So that's usually the simple part. If you see coefficients, you just take the largest common divisor out. But the second part, the way you do the variable, you will take all common variables raised to the smallest power. Now, what I mean by that, in this example, the common variable was x, right? X was in both terms. So then you look at, well, what is the lowest power of x? You have x to the power 1, and you have x to the power 2. You take the lowest. So if you just stick with that, if you understand the idea of the lowest power, then I can put negative exponents in there, whatever that means. I can put fractional exponents in there, whatever that means. Just always take the lowest power of the common variable. Just if you stick with that, you're always going to be able to find the proper GCF. And to factor, you'll have to divide each term by the greatest common factor. So that's how you know what's left. So let's try this. 6x squared y cubed minus 12x to the 4th y squared plus 9 x squared y z. Some nonsense like that. So in order for me to find the greatest common factor, first, I'm just going to look at the numericals, 6, 12, and 9. And I'm going to take the largest number that divides 6, 12, and 9, which is what? 3. So 3 goes into greatest common factor. Then I'm going to start looking for the common variables. X is in each term. Do you agree with that? And what is the lowest power of x? X squared. Y is in every term. What is the lowest power of y? Just y to the power 1. I also see a z in there. Is z in every term? No. So we're done. This is the greatest common factor. 3x squared y. You just take all the lowest power of common variables. And then in order for you to factor 3x squared y, just think about dividing each term by that expression. So if you divide 6x squared y cubed by 3x squared y, what is left? If you divide first term by the GCF, 2, well, why is there an x? Yeah, so x's will cancel, x squared cancels, then you remember, you subtract exponents, right? So y cubed divided by y is y squared. So that's what's left out of the first term. What about the second term? Anyone? 4x squared y, so you just subtract exponents. 12 divided by 3 is 4, and the last one is what? Plus 3z. Okay. Question? So I had x to the 4th, and I'm dividing it by x squared, so we just subtract exponents. So that's x squared. And again, when in doubt, distribute. Distribute your greatest common factor through the parenthesis. You should get your original example, or your original problem back. Is that okay? Okay, good. How about this example? 4x to the negative first power. Whatever that means. Do you guys understand negative exponents yet? What are the negative exponents? You don't understand negative exponents? We'll talk about them, but let there be negative exponents. Let's make an experiment. If you understand negative exponents, good. If you don't understand negative exponents, that's good too. I just want to try it and factor that. See whether we can follow our two-step process. So what is the greatest common factor? What is the numerical part? Well, okay, 4, now x. There is x in every term. What is the smallest power of x? Negative 2. So you factor out x to the negative second power. Just stick to the smallest powers, always. Okay? So you don't have to think about this. And what is the smallest power of y? Just y. Okay, that's the GCF. This is the greatest common factor. You always go for the smallest exponents. So if we factor this out, well, what's left then? This is going to be the fun part. Why? Well, you got to give me a reason. You just yelled out an answer. Why is it x to the negative first power? How do you get what's in the parentheses? What is that final thing? How do you go from here to the factored form? Divide, right? So let's divide. What do you do with exponents when you divide? If I ask you, what is, x to the power 7 divided by x to the power 3, what do you do with exponents? You subtract exponents, right? You know the rules of exponents. So, that's still valid. So 4, that's gone. Y, that's gone. But now you're dividing x to the negative first power by x to the negative second power. You have to subtract exponents. What is negative 1 minus negative 2? Positive 1. So you're actually going to end up with a pretty little x. You subtract exponents. What happened there is negative 1 minus negative 2, which is positive 1, so that's x to the power 1. So we subtract exponents. That's, nobody changes that rule. And then there you get plus 2, x negative 2, that's gone. And then y squared and the y, you're left with a y. So when you just write it as a pretty answer. So it's 4x negative 2y times x plus 2y. If you try to factor any power other than negative 2 from this problem, both terms will have at least an x in it. And that's not good. You always want to have, so there's nothing else that you can take out. Okay? But again, if you just stick to that idea, lowest power, so just always take the lowest power, and then to figure out what's left, you just divide. So you subtract powers. So, that's the same process, a little weirder because of the negative exponents, whatever they mean. How many of you know what negative exponents are? Over there? Yeah, we'll talk about that. But not an issue right now. Is that good? Okay. Let's try this problem. 6, I'm going to leave a little space squared plus, what's a good number? I don't care. 3, I'm going to leave a little space cubed. And where the space was, I'm just going to put a little smiley faces. All right. That's a problem. I want to try to factor that. What is the greatest common factor here? So 3. What? So smiley face squared, right? So you just noticed the common part and you took the lowest power. That's right. So you're going to take the smiley face squared. That's the greatest common factor. Right? This is the part that they both share. It doesn't have to be a variable, just whatever looks the same. Take it out to the lowest power. So then, that's too many smiley faces. Okay, I'm going to get lazy. I'm going to write it like that. So what's left? What goes in the parentheses? 2 plus, okay, that's, yeah. Is that okay? So it's the same concept. While I'm bringing this up, the reason why I'm showing you this example is if I give you something like this, 5x times x minus 4 minus 3 times x minus 4. Is there a common factor? The way I look at this problem, I have two expressions separated by a minus. So these are my two expressions. Is there a common factor among those two expressions? 1. Well, 1 will always work. Is there anything else? Well, first one is 5 times x minus 4. The other one is 3 times x minus 4. In order for me to say that x is a common factor, the next one also have to have multiplied by x to whatever power. So x only belongs to the first one as a factor, right? X by itself is very much different from x minus 4. It's like 11 and 7, two numbers that differ by 4. They're very different numbers. So, but is there a common term between these two expressions? X minus 4. X minus 4 is the common factor. That's the smiley face. It's just something that both terms share. So in this case, the greatest common factor is in fact that entire binomial of x minus 4. That's what the both long factors, long expressions share. So if I take x minus 4 out, if I factor x minus 4 out, what is left? 5x minus 3. So that's about that. What? Question? Yeah. So it's just like the smiley face. You found the common thing, you take that out. Does that make sense? What if I do this one? 5x, x minus 4 minus 3x squared, x minus 4 cubed. If I go a little crazy on you. X minus 4, what? I also added a few other things here. So again, these are your two factors. These are your two expressions. The only things that are separated by plus or minus, these are the ones that were a factor. This is expression 1. That is expression 2. So I want to pull out everything that expression 1 and expression 2 share. So what do they share? Yes, x minus 4. I agree with that. Is there anything else that both things? Is there another factor that belongs to both expressions? Just x. So the lowest power is 1. So it's x times x minus 4. That is the greatest common factor for these two expressions. So if I pull x times x minus 4 out, then what is left out of the first expression? 5. Then you follow the sign minus, and what is left out of the second expression? Minus 3x, right? You had x squared, you took x out. What the whole thing? You're guessing. That's the problem. Just follow the steps. 3 stays, x squared turned into x because you took x out. What about x minus 4 cubed? What's going to happen with x minus 4 cubed if you took just one x minus 4 out? What's going to be left? Well, x minus 4 squared, right? Yeah. You said the whole thing squared. That's maybe that if that's what you meant, then it's okay. So it's the same process. You're reducing powers, you subtract exponents. So whatever nonsense this is, we're done factoring. You can then open up parentheses, whatever. I don't care. For now, we're done factoring. Does that make sense? How you take something like that out? So again, your greatest common factor does not have to be just variables. It could be other algebraic expressions, weird symbols, whatever. You'll see problems where they're just weird symbols, some Greek letters or whatever. But the same concept stays. How's that? Is that okay? All right. So the next form of factoring, so first, we understand how to take the greatest common factor. The next form of factoring is called factoring by grouping. And again, I'm just going to start you with an example. So let's say we have something like 2x cubed minus 3x squared plus 2x minus 3. So here's an expression. The one thing you need to understand and kind of use it in all future attempts to factor something, no matter what the problem is, first, look for the greatest common factor. Because it will make your problem smaller if there is one. So, first step, look for the greatest common factor. Is there a greatest common factor in that expression? Is there a term that is shared by all 4 little parts? has to be common in all four parts. So is there a greatest common factor here? No. But that's what you should look for first. Look for the greatest common factor. But another thing you should probably make a little side note. When you're faced with a expression that has four terms without a greatest common factor, four terms, no GCF, the only way to do that problem is to factor by grouping. Okay? Now, the way we do that, does anybody know how to do factoring by grouping? The way we make an attempt to factor by grouping when there is no common factor, we're going to group it into the first two terms, most likely, and the next two terms. So, just look at the first two terms. Ignore everything else. Is there a greatest common factor among first two terms? X squared. So I'm just going to do that. I'm going to take x squared out of the first two terms. If I do that, what's left? Three, right? In order for factoring by grouping to work, you want to get another 2x minus 3 out of the remaining two terms. Well, the remaining two terms is just 2x minus 3, right? I'm going to write it like this. I'm just going to throw in a pair of parentheses around 2x minus 3. Is that okay? You know, I can just put the parentheses, there's a plus in front. Nothing bad happened. Well, so that was the first step. Well, now think about what we just did in the previous set of examples. I have two expressions separated by a plus. Is there a common factor among those two expressions? 2x minus 3. So we're going to pull out the 2x minus 3, just like we did in the previous examples. And if I do that, we're left with x squared plus what? Well, I just took 2x minus 3 out. So what's left? 1. Again, think about the division. If you're in doubt what's left in the parentheses, just divide. 2x minus 3 divided by 2x minus 3, it's 1. That's it. So we just factored this expression in two steps. First, group them 2 by 2, pull out the greatest common factors out of each pair. But you really want to get a match. You really want to get a parenthesis that matches. And then you take that parenthesis out. Now we can do a quick check. You don't have to do that, but just a quick check. And that's a good review. If I FOIL this thing, I should get the original problem back. If I don't, I did something wrong. Well, since you already know how to FOIL, 2x times x squared is what? 2x cubed. 2x times 1 is 2x. Negative 3 times x squared is negative 3x squared. And negative 3 times 1 is negative 3. Is this the same as what we had originally? Written in different order, but that doesn't matter. It's the same expression. Is that okay? Okay, let's try another one. So let's do 4x cubed minus 8x squared minus minus 6x. Do I really want a 6x? I think so. Plus 12. I don't know. I think that should work. Oh, no, that's a bad example. Oh, that's a good example. Let's do this one. Okay. So what's the first thing I need to do? That's not the first thing I need to do. What is the first thing I need to do? Always when faced with a factor in question. check for the greatest common factor. It will make your life a whole lot easier if you pull the greatest common factor out. Is there a greatest common factor? Yes, so let's pull the 2 out. 2 times 2x cubed minus 4x squared. That's a bad example. I don't know. I don't know what I was thinking. No, it's actually a good example. I keep bashing this example. I don't know why. I lose faith in it and like gain it back. Okay. Is there a greatest common factor of whatever's left in the parentheses? No. But already we pulled the 2 out. 2 is a part of the answer. 2 is one of the factors. So then the rest, we're going to start grouping. So take a look at the first 2 terms. Is there a common factor among the first 2 terms? Okay, which is what? 2x squared. So let's pull 2x squared out. What is left? If you pull 2x squared out, x minus 2, right? Just the first 2 terms. Before we go any further, keep in mind, in order for this to work, I need another x minus 2 to appear. So that's what you have to keep in mind. In order for this problem to be workable, another x minus 2 has to appear. So what should I pull out of the remaining 2 terms in order for us to get another x minus 2? Because right now it's negative 3x plus 6. So I need to take something out, so I'm left with positive x, negative 2. Well, if I take 3 out, then I'm left with negative 2x plus 2. So take negative 3 out, right? Because these signs have to change. Negative has to become positive. Positive has to become negative. So in order for that to happen, take out the negative 3, and then again, you do the division. It becomes positive x and negative 2. So if you have to flip the signs, take the negative out. Okay? So now, again, this first 2 is just part of the answer. Nothing, it doesn't go anywhere. I'm just copying it down. Now let's look at what's left. Whatever's left, what is the greatest common factor among x minus 2? So I'll take x minus 2 out. If I take x minus 2 out, what is remaining? 2x squared minus 3. So that's our answer. So again, first thing was find the greatest common factor. And we had a little one. We'll pull the 2 out. Okay. Otherwise, it would be a little messier. So we pulled the greatest common factor, then we started grouping. First 2 terms, pull the GCF. Last 2 terms, pull the GCF in a way that you get the repetition of that term. That's what you want to get. If it doesn't happen, it won't work. So we had to change the signs by taking the negative out. And then you take in that common term and then see what's left. So if you take x minus 2 out, we're left with 2x squared and a negative 3. Any questions on this? Is that okay? All right. Well, let me put you to work. We'll do like a mid